Hello guys, how are you? I hope that all of you are in good shape and healthy and safe. I'm going to record some videos for you and I will post it on SB through YouTube. Please follow these videos that will explain the stuff. Those will explain the stuff that we need to cover for this course until I see you again in room 131. We are going to start Unit 4, and Unit 4 is talking about the derivatives of exponential, logarithmic, and trig functions. Before I start, I want to review some topics that will help us remember the stuff that we need for finding the derivatives and the calculus work. So before I start the calculus work, I will review some algebra stuff that are needed. The first thing I want to remind you is exponential functions. So exponential functions. Those are the functions in the form of f of x equal a to the power of x. We call a the base and x is the exponent, and this is how the function looks like in the parent function of the exponential, so without any expansion or compression or shifting left and right or anything. All the exponential functions have graphs, has some features. All of them has a horizontal asymptote at the x-axis. So as x becomes very small, y approaches 0. So the curve is always when x goes to negative infinity, y goes to 0. So as x goes to negative infinity, y goes to 0. This is the first feature. The second feature is it is growing fast. Fast growth. So in other words, as x goes to infinity, y also goes to infinity. So fast growth, this is the second feature. So the first feature was a horizontal asymptote. The second feature is fast growth. The third feature, it is always has a y-intercept at 1. So when x is 0, y equals 1. This is the features of any exponential function, regardless the base. The base could be 2, 3, 4, as long as a doesn't equal 1 and a is greater than 0, the graph will look like this. So a is greater than 1. If it's a fraction, the curve will flip, but for now we need to study this, to remember this as it is. We are going to discuss more as we go. So this is the exponential function. One of these exponential function is when the base is e. So when the base is e, this is a special exponential function. So if f of x equal e to the power of x, this is an exponential function with base e. So before we proceed and we say y makes this function special, we have to talk about what is e. So e is the natural number. It's called the natural number. E almost equal 2.71828, and it will never end. E is an irrational number. E cannot be written in the form of a over b because the decimal is endless. This is what e, the name of e, natural number. The value approximately equal 2.71828, and it keeps going. And it is irrational number. It cannot be written in the form of a over b. So what is the definition of e? E is the base of an exponential function where the slope of the tangent line at x equals 0, between brackets, this means y-intercept, is equal to 1. In other words, we know that the slope of the tangent in calculus, we call it the derivative. In other words, f prime of 0 will equal 1. So, again, e is the natural number. It is irrational number, endless, decimal, almost equal to 2.71828. Its definition is that it is the base of an exponential function. So this is an exponential function. This is the base. E is the base of that function. When or where the slope of the tangent line to the curve of the exponential function at x equals 0, which is the y-intercept, equals 1. So if we draw a picture, if we draw a graph of the function e to the power of x, this is x and this is e to the power of x. The same features we have seen before in the exponential function. It will have a horizontal asymptote at y equals 0, or the x-axis. It has a y-intercept at 1, and it is fast growing, as you see. The only difference is if we draw a tangent line to this curve at this point, the slope of the tangent line equals 1. The slope of the tangent at the y-intercept equals 1. So that is E. Okay? This is the graphical meaning and definition of E. I want also to give you another definition using limits. So, if we write the limit as n goes to infinity, 1 plus 1 over n to the power of n, this is equal to E. So, for example, if n equals 1, we will find that 1 plus 1 over 1 to the power of 1 will be 2. If n equals, what's the name? Oh, 100. It's 1 plus 1 over 100 to the power of 100, and we find that this equals 2.7. So when we come to 1000, 1 plus 1 over 1000 to the power of 1000, this will equal 2.7169. So as you see, we are coming close to E, which is 2.71828. So as n comes close to infinity, getting bigger and bigger, this limit goes to E, comes close to E. So when n is 1 million, 1 plus 1 over 1 million to the power of 1 million, this will equal, yes, 2.71828. So this is the second definition of E using the limit. Okay, I will end this video right now. I will post it, as I said, and I will start another video with an important limit and how we find the derivative of e to the power of x and e to the power of f of x as a composite function. Okay. Also, I want to review some topics related to logarithmic functions. Okay. Thank you for watching.